Okay, 2010 parametric FRQ tells us a particle is moving along a curve so that its position at time t is x of t and y of t, where x of t is equal to t squared minus 4t plus 8, and y of t is not specifically given, or not explicitly given, excuse me. Both x and y are measured in meters, t is measured in seconds. It is known that dy dt is equal to t times e to the t minus 3 minus 1. So this is kind of a unique scenario in that we've got x of t and then we've got y prime of t in for this question. So they give us like half and half. So first part of this says find the speed of the particle at time t equals 3. So this is really about knowing the formula. This is actually just a 1-point question. So our speed is going to be equal to the square root of x prime of 3 squared plus y prime of 3 squared. Oh, that's it. I was gonna do a d theta there. So we don't need that. Now, it's really plugging stuff into the calculator. Now, you're probably wondering, should you be in parametric mode? Should you be in function mode? You can be in either one. So here's what I recommend doing. So I'm going to go to y equals, and I'm going to plug in, check my mode. I'm going to want to be in radian mode, and I want to be in function mode for this problem. Now, when I go to y equals, I'm going to plug in my x equation. So that's x squared minus 4x plus 8. And then I'm going to need the derivative for this equation. So I'm going to put in y2. I'm going to have that be the derivative of y1. So I'm going to do math 8, x, and then here I put y1, evaluate it at x. And then y3, I'm going to put in my y prime, my dy dt. And that is x times e to the x minus 3 minus 1. Now by having these all in, y1, y2, and y3, it's going to make plugging the speed equation in a lot easier. So I'm going to go back to my original window. We'll get the square root, and now I want x prime of 3. I know that x prime is in y2. y2 of 3, but I have to go back because this has got to be squared, so I need to insert a parentheses there. Parentheses, we'll square that. So that's my x prime of t, or x prime of 3 squared plus, parentheses again, and then my y prime was in y sub 3, square that, and then that's my calculation. Hit enter, and I end up getting my answer, which is 2.828, and that's just a 1-point question. They did not specify that they wanted units, so you do not need to include units for the answer. Okay, question B. By the way, it's also nice we have all the stuff in our calculator now to set up to do the rest of the problem. Question B, it says find the total distance traveled by the particle for t between 0 and 4. So, total distance, it's a matter of knowing that formula.
Good afternoon. At this time, College Fair 3 students who attended Sea Lunch are now excused to attend the College Fair in the Lindbergh Center. Thank you.
We need to have this equation for the total distance traveled, x prime of t, y prime of t. The calculator is going to do the work for us here. So we've got all that in our calculator already. So now we'll do math 9 from 0 to 4. And we'll do the square root. And now I've got my equations already in there, so I've got y of 2 and y of 3. Those are the ones I need. I'll trace to pull those up. So we'll do y sub 2 squared plus y sub 3 squared dx. It's thinking. And it gives us our answer of 11.587, or we could do 11.588. This is a 2-point question. You're going to get a point for setting up your integral, and then a point for your numeric answer. Question C. Question C says, find the time between 0 and 4 when the line tangent to the path of the particle is horizontal. Is the direction of motion of the particle toward the left or the right at that time? Give a reason for your answer. So we really want to look back to the stuff that we reviewed. So we're talking about a horizontal tangent line. We have a horizontal tangent line that indicates that our derivative dy dx is equal to 0. For the derivative to be equal to 0, that means that y prime of t equals 0 and x prime of t does not equal 0. So what I need to find here is I need to figure out this t value. Where is y prime of t equal to 0? Remember, it's a calculator question. We're going to have the calculator do the work. So I'm going to go back to my calculator. I'm going to go to y equals. Now I want to isolate my y prime graph. Now, because I have a colored screen, this is pretty easy to do. For those of you that don't, you may want to turn these other graphs off so they don't get in the way. And then to graph it, I'm going to specifically put in my x min and x max to go from 0 to 4, because that's my time frame. When I hit graph, we'll see that we cross the x-axis at this point right here. So we want to find that value by doing second trace 0. So the left side, turns out I'm right there, and then I just have to arrow over to the right side, hit enter, enter again, and it tells me that t value. So t is equal to 2.208. Now, we need to verify that if we plug 2.208 into x prime of t, that it does not equal 0. Just by kind of taking a look back at this function, or x prime of t, x prime of t is equal to 2t minus 4. We don't have to worry about this being true. So this, this is, x prime of t is not equal to 0 at t equals 2.208. Now the second part of this question says, is the motion of the particle towards the left or the right? Remember, the left or the right is all about the sign of x prime of t. Is it positive or is it negative? So what we need to figure out is what x prime of 2.208 is. Now we've got an equation for x prime on our calculator. So again, we want to use that to our advantage. So x prime is in y sub 2. So I'm just going to bring up y sub 2, and I'll plug in 2.208. This gives us back a value that is greater than 0. What the value is actually doesn't even matter. We just need to know that that's greater than 0, and this indicates that the particle is moving towards the right. And a particle is moving towards the right because x prime at 2.208 is greater than 0. So how many points is this question? This question is worth 3 points. Considering this piece right here is a point. Finding this t value is another point, and then this whole analysis down here is your third point for this question. So we're at a total of 6 points all in for this question from 2010. Question D says there is a point with x coordinate 5 through which the particle passes twice. Find each of the following: the two values of t when that occurs, the slopes of the lines tangent to the particle's path at that point, and then find the y-coordinate of that point given that y of 2 is equal to 3 plus 1 over e. So this is a lot of stuff in this question that we've got to keep track of. So it says there's a point with x-coordinate equal to 5 that the particle passes twice. So we know our x-coordinate. We know our x-coordinate is, or I'll say our x of t, that's equal to t squared minus 4t plus 8. We want to know where this is equal to 5. We can do this by hand, or we can use our calculator if we want to find those values. I think we can do this by hand. I would subtract 5 here, and I'd get t squared minus 4t plus 3 equals 0. And this easily factors. So we get t equals 1 and 3. Now, if it wasn't easy to factor, you would want to graph this. And what you'd want to graph is this piece right here. You would want to find the 0 when you graphed your x of t once it actually is equal to 0. So these are the two values that the x-coordinate is equal to 5. That's our first point for this problem. So that's part 1 of part D. Part 2 of part D says find the slopes of the lines tangent to the particle's path at that point. Again, we want to use our calculator. So we're looking for dy dx at t equals 1, and we're looking for dy dx at t equals 3. Our calculator has the elements we need for dy dx. So we know that, we'll go back to y1, or y equals, that y prime is in y3 and x prime is in y2. So the way that I can quickly get the slopes is by doing alpha trace of y3 of 1 divided by y2 of 1. And that gives me that value. That's 0.432. Because remember, dy dx is just y prime over x prime. Now, I can do the same thing at 3. And to make my life easier, I'm going to just bring this part down again, and I'm going to plug a 3 in. Each spot I had a 1. It's the same calculation. And that slope gives me exactly 1. So if I got both of these slopes, that's the second point of part D. Now let's take a look at part 3 of part D. So this one says find the y-coordinate of that point, given that y of 2 is equal to 3 plus 1 over e. So give the y-coordinate of that point. So that means it could be, I could use 3 or I could use 1. And I'm given a point for y sub 2. So I'm going to do the integral of y prime of t dt from 2 to 3. And that should give me back y of 3 minus y of 2. I can get this value on the calculator very easily, and we know what y of 2 is. So I'm going to do math 9 from 2 to 3 of my y prime, which is in y sub 3, and we get that value. So I'm just going to kind of leave that on the calculator, but that's roughly 0.632 equals y sub 3 minus y sub 2, or y of 2, not y sub 2, which they say is equal to 3 plus 1 over e. So that means y of 3, I'm going to get by adding the 3 plus 1 over e to 0.632. So I kept this and I didn't want to round that, I'm just going to keep it where it's at. And now I'm going to add 3 plus 1 divided by e. Let's put that in parentheses. And we get 4. Kind of crazy. So that's our final point for that question.